So acid anhydrides. Acid anhydrides, I think, are awesome molecules. They're quite reactive. Think about why they're quite reactive, compared why they're more reactive, for example, than carboxylic acid, which is already quite reactive. So acid anhydrides can be formed from the condensation of two carboxylic acids. If it's condensation, it's because we have removed water, removed our small molecule, which in this case is water. They are more reactive than carboxylic acids and can also react with alcohols to form esters. Why are they going to be more reactive than carboxylic acids? Why is a carboxylic acid reactive? Thinking about mechanisms and where mechanisms come from, why are carboxylic acids reactive? The bit about carboxylic, or one of the bits, I should say, about carboxylic acid that's reactive is that delta positive carbon. The carbon, which has had electron density stolen from it by the single bond oxygen and by the double bond oxygen. So that carbon is considerably delta positive because it's having electron density stolen away from it by two electronegative elements next door to it. With an acid anhydride, we've got the addition of these extra electronegative elements. So you're going to get a lovely delta positive carbon, but also the presence of that like double group, as it were, adds instability to the molecule because you've got this division of charge all across the molecule. So makes it even more reactive than carboxylic acids. So they can also react with alcohols to form esters and carboxylic acids. Carboxylic acids. Let's give us an example. So, oh, that's funny. This is our alcohol, and we can form our ester. Again, this is not a mechanism that you need to know, but I'm going to add it in because I think it helps us to work out what's going on. You can get the attack of the lone pair on the alcohol can attack the delta positive carbon. You get the pair of electrons in the double bond flipping up onto the oxygen. They can then flip back down again, and it breaks the carbon-oxygen bond, separating the molecule, or breaking the acid anhydride bond. And then we end up with one species, which is our ester, that has been attached to the alcohol. So we get that's the alcoholic oxygen. And then the rest of it is the carboxylic acid, which can accept the spare hydrogen from the alcohol to become a carboxylic acid. I'll draw it that way around to make it a bit easier to see. So we can get an ester and a carboxylic acid. Carboxylic acid. This is not a direct mechanism because obviously you'd need to show the step that removed the hydrogen. You don't have to do these mechanisms, but it's just, I think, worth considering, worth thinking about. So this is our acid anhydride. Ooh, that handwriting's not great. Acid anhydride. That's not much better. Okay. What else do I want to say? There are, again, other ways that you can form acid anhydrides, and there are other reactions you can do with acid anhydrides. This is just an example of one.